this next session. So this is the fifth session on the Fusion API, and so thanks for hanging with us and attending again. So I'm Brian Ekins, the API designer for Fusion, and today I wanted to cover a topic that I've just called document structure, for lack of a better name. And so let's go ahead and get started here. So I wanted to use an analogy that I hope makes some sense with all of this, and just that it's kind of all about containers. What these chunks that can hold data, and so a little bit more about what I mean with that. So we've got a document container. So that's the high level container that holds everything. So just above that we have the application. That's not a container. That's just that knows how to look at documents and display them, and so it's the thing that does stuff with documents. So it's not data itself, but the document is the big container for all of our data. And in Fusion there's always a document, an active document. So when you just first open Fusion, there's a document open. It's just an empty one that you could start building in. If I close every document, there'll always be, Fusion always keeps a document open, so there's always an active document. But through the API you can also access non-active documents. So typically you want to work on the active one because you're writing some, your add-in is typically a command that will do something on the document that the user is currently working on. But through the API you're not limited to just working with that document. You can get other non-active documents and add geometry or query them or do whatever you want with them through the API. And through the API there's a class called document, and that's the base class, and derived from that is there's a class called Fusion document. So that's and it's represented, if you actually save it to disk, it's an F3D file, but that holds all of the 3D data. So for design, CAM, SIM, whatever else comes in the future, that document holds all of this kind of data. And the other document type will be in the future a drawing document, which is saved as an F2D. And this class doesn't exist yet in the API because we haven't done anything API-wise around drawings yet. And so today, since it doesn't exist, if you have a drawing open and you ask the application, well, give me the active document, the API will return a document object rather than a drawing document. But if there's a 3D document open, you'll get back a Fusion document. All right, so inside products, so we have this, or inside a document, so we have this Fusion document, so that's the big container. And then inside that, we have what we refer to as a product, and that represents a particular type of data. So we've got another container that sits inside this Fusion document container. Right. And so we have these products, and so one type of product, so product is the base class, so that represents all these different types of data. But a specific type of data is a design object. So design is derived from product. It's a type of product, and it contains all of the Fusion data. And there's always only one, and but there always is one in a Fusion document. So you can always count on there being a design product, and there's only ever one. So we have this chunk of data that has all of the Fusion design data in it. And then there's also other products. There's a CAM product, which doesn't really exist through the API yet, but will. So you can access CAM data that's inside a document. There's a sim study document, and then sim cases. And so the CAM and all the sim stuff is futures. But just to illustrate how there's these chunks of data in a document. So all the design data is in one container, all of the CAM data is in another container, the sim study is in a container, and then each case that you create has its own container. And so it's all segmented. And these other ones, so Fusion, there's always a container of design data. And for these other ones, there may not be a container until the user actually creates some of that data, and then the container is created and data is put into it. All right, so let's look in a little more detail at the design. So with design, say there's always one and only one. So there's a one-to-one relationship between the design data and a Fusion document. And the design data, the design object just has, so it's Fusion specific data that applies to the whole document. And so you can see here, if I get the design, I can export data, I can get what units I'm currently working in, a list of all the parameters, the timeline, user parameters, and something, and I'll go into more detail on this, something called the root component, and I can get other components too from the design. But that root component is pretty critical. So a component is really where all of the interesting information is as far as a Fusion design object. So here's from the object model chart, the object that you can't really see, but the big one across the top, that's the component, and here's all the stuff it owns. So it really owns, all the interesting stuff that you think of as a part of an assembly. So it has all of the features, all of the model data, the part data, the shape of the part, mesh bodies. It has all the assembly information, joints, sketches, construction geometry, and so here I've simplified it a little bit and just taken the top level things that are directly available off of the component. So you can see there's a lot of data inside the component. So here's generally what you would consider as being kind of part related data, and here's what's usually assembly related functionality, and then the others tend to be both, could be used in either. But Fusion doesn't differentiate between parts and assemblies. So you have a component and it just contains all of this data. So but generally people will create, a component and it just has part data in it, or they'll create a component and it just has assembly information in it, and not mix them, but they're not limited to doing that. So the root component is kind of a special container, and so I got this picture just to show that it's a clear container. I can see what's inside it, and I can go in and manipulate the data that's inside it. And a root component has a one-to-one relationship with the design, and it's represented in the browser by the top node inside the browser. So that widget, that represents the root component. So that's so you have a document, and then inside that document you have the root component container, and that really, that's going to contain everything else. So that root component is very important. And so that root component, provides access to these top level ones that you see in the diagram on the right. So you can get all of that. And then you also have, besides the root component, you have other components, because when I'm building a model, and we'll look at this in a second, is I can say create a new component. So those aren't root components, those are components inside the root component. So I'm differentiating here. They're root component and regular component. They're both represented by the component class. So in the API, there's no difference in the functionality that they have. But the root component is just the special one because it's the big container that holds everything else, including other components. And so these regular components are the other components that would exist within a root component. And like I say, they typically represent a part or a subassembly, but they can be a mix. And components are always aligned with the world coordinate system. So a component's coordinate system, every component has the same coordinate system, and they all lie on top of each other, where their origin is all at 0, 0, 0. X is in the world X, Y is in the world Y, and Z is in the world Z. So, and components can't be moved. They always are at that same coordinate system. And you might be thinking, well, I can move a component, but I'll show you that in a second. Right, so in the UI, when you add new content, it's added to the active component, and I'll demonstrate this in a little more detail if you're haven't used Fusion a lot. But so basically I'm saying I want this to be the active container, and so I pick a component, and now if I draw sketches or construction geometry or whatever, create a new body, that goes into that component. But through the API ignores what the active component is. If you care about it, you can find out from the API which component is active. But when you're making, say, when you create a new sketch, it doesn't care what the active component is. And the way it determines where to create that sketch is by where you got that sketches collection that you call the add method on. Right? So when you were traversing that object model, you started at probably the active document, and then maybe got the root component. And so if I get the sketches collection from the root component, then that sketch is going to be created in the root component. It doesn't matter if some other component is active or not. But if I go to another component and get the sketches collection from it and call the add, then the sketch will be created in that component. And so it's independent of what's active in the UI. And this is in general, the way the API behaves is it's independent of any user settings. And this is intentional so that when I write a program, I want it to behave the same all the time, regardless of the state that the user has put Fusion in, or particular settings that he set. All right, so sketches are another container, and obviously you can create any number of sketches, and they exist in a component. So they're another container that sits inside the component container. And sketches and sketch geometry are all three-dimensional. And but typically sketches are used as 2D, and by default, when I create a new sketch, Fusion orients the view so I'm looking on the XY plane of that sketch, and as I draw, all the geometry is on that XY plane. But it's possible for me to go in and modify it and pull it off of that XY plane. So it really is creating 3D geometry. It's just usually it just is all flat on the XY plane. And sketches have their own coordinate system. And so as I'm drawing geometry in that sketch, that geometry is being placed relative to the sketch coordinate system. And each sketch is positioned within the 3D model space. So when I say create a sketch and I pick a face, Fusion figures out how to create that new sketch. So the XY plane is on top of that face, it aligns with that face, and it infers some kind of orientation and builds the sketch. And so that sketch has its own coordinate system, and the geometry inside it is relative to that. So if I create a sketch and then start drawing lines, the XYZ coordinates that I provide for those lines are going to be relative to the sketch coordinate system, not the model coordinate system. And if you create a sketch using one of the base coordinate systems, say the XY base construction plane, then it happens to line up with the model coordinate system in that case. But in general, they don't. They'll be in some other position. And there are ways, the sketch object has ways to find out what its orientation is and to convert points from the sketch coordinate system to the model coordinate system, so you can go back and forth. So this is something that's a little bit confusing in Fusion, and the UI kind of makes it confusing. So I mentioned before that components are always aligned with the model coordinate system and cannot be moved. And that's true. And so instead, what can be moved is there's something called an occurrences. And in the UI, when you're looking at data inside a Fusion model, the data you're seeing is either data that's in the root component or it's data that's in some other component. And if it's in another component, you don't directly see that data. So it's like this opaque container. So the root component is that nice transparent container that I can see all the data, and this is talking about from the UI. I can see all the data, I can manipulate it. But if I create other components, they're this opaque container, and from the UI, I can't ever really see the data that's inside that component directly. And instead, what I see is an occurrence of that component. And one way, so an occurrence is it references a component. And one way to kind of think about what an occurrence is, this isn't how it is, of course, but a way to visualize it is, so I have a part inside this opaque box. And what the occurrence is it's like just a perfect hologram where the contents of that box is being projected into my assembly. So now I can see the contents of that box. It looks like it's really there, but it's not. I'm just seeing this projection of the contents of that component. And I can have multiple occurrences that reference that same component. Right? So I could have, say, multiple bolts. So the bolt data I can't see because it's in this kind of invisible component, but I see these multiple occurrences of that bolt. If I edit any one of them, all the others change because they're all reflections of the same component. So where this gets, I think, a little confusing is occurrences in the UI, the UI calls them components. So it names, when I create a new occurrence, it names it component 1, component 2, but it's really an occurrence that's referencing component 1 or referencing component 2. All right, so let me just do a little demonstration here to show better what I'm talking about. All right, so here we have Fusion. And I'm going to go kind of slow here because it's just slow for everybody's screen to update. Right. And so if I just create a box, and if I say I just want to create a new body, click OK. Right. So that body was created in the root component. So I'm looking at the real body now because it's in the root component. And instead now we'll create another box. And this time I'll say I want to create a new component. All right, so Fusion just created a new component that I can see in the browser. And if I expand that, I can see it contains a body. Right. So, but that body I'm looking at isn't a real body, it's a reflection of the body that's inside the component. And I can't really, there's no way through the UI to see the real body. It's always a reflection of the body through an occurrence. So this is really an occurrence. So it's not the component, it's an instance of that component. And if I do copy and paste, okay, so now I have two occurrences and they're both instancing referencing component 1. So I have two instances of component 1. And we can see here if I create a fillet on this edge, all right, both of them change because they're both referencing the same component, right? They're both, like I said, the analogy is they're both 3D holograms that are being projected by looking at the same part. So when that part changes, both of these reflections update to show that change. So when I make this change, I'm not really picking the real body, I'm picking the reflection of it. So the UI makes it feel like that really exists there, but it's just a reflection and an instance of the real component data. One thing, if you're playing with this, that can be a little bit confusing is let's say if I pick this body and copy and then do paste. Okay, it all looks kind of the same, but now if I do a fillet, okay, just that one changed, and that's because I copied the body. So that actually took the geometry that was inside that component and it created a copy of it, and so now I have two separate bodies, and so I'm editing the real body instead of an instance of that. In fact, that body you can see it was even copied into the root component. So So that's a real body. It's independent of this body. It was just the geometry just started as the same shape as it. It was copied, but there's no link between them anymore. So we have these two occurrences, and I'll go ahead and delete this one. So, all right. So let's go back to the slides here for a minute. And so another thing with this is that occurrences can contain other occurrences. Right? So this is for subassemblies. So we have a component. So let's say this is the root component, and then I can get occurrences from it. So that assembly that we just built, if I go to that component and get its occurrences, there were two occurrences. And it's possible that those occurrences could have other occurrences inside them. And so that's where, let's see, let me go back. So here I can say, let's create a new component. And then I can, inside that one, even say create a new component. And the icon changes. So Fusion is indicating to me that this contains another component, and so this is behaving like a subassembly. So I have a component that contains another component, and this could be any levels deep. And so the API provides access to that. So I can go to an occurrence, I can get the occurrences that are inside it, and then for each one of those occurrences, again, it has a list of the occurrences inside it, and so I can traverse that occurrence tree and get the same information that I see in the browser. I can see all these nested assemblies. All right, and I said before that components can't be moved because they're just this kind of hidden data that's always at model space, but occurrences can be repositioned. So I can move those around, and that's what's happening in the assembly when you grab a part and move it around, or when you're adding joints between parts, that's really controlling the position of these occurrences. So the real data that's inside the component isn't changing. It's just the position of the occurrence, so that it's like that hologram is being moved around, but the real data that's being read to display that hologram is fixed in space. All right, so here's a problem, and we've said that multiple occurrences can reference the same component, just like what we saw a minute ago in that little assembly that we built. So we had two occurrences that reference that little block with a fillet on it, like this. So we've got two occurrences, right? So, and they're both referencing component one, which is in this opaque thing. So there's the real data is inside the component, and these two occurrences are referencing that data. All right, so the geometry, the real geometry only exists inside the component. And these occurrences that I see and interact with on the screen as a user are just reflections of that real geometry. So here's kind of the problem is, so now I have that face, so a particular piece of geometry, and so how do I reference that face when really that face only exists once, right? In the real part that's inside the component, that face, there's a single instance of that face. But now when I look at occurrences in the assembly, I see two of those faces. And so through the API, how do I identify one of the faces versus the other face? And that's done through something we refer to as a proxy. And so everything that's selectable in Fusion can have this proxy behavior. And what proxies do is they act like the real thing. So if the user picks that face that I had highlighted in the previous slide, and you get that face through the API, you'll get back a face object. But it's not the real face object, it's a proxy of that face. So it's acting as that face, but as the face that was selected, because they're different, right? One face is in one position and the other one's in another location in the model. And so when I query that face to get information from it, one of those faces will return different information than the other one because they're in different locations. So these proxies behave like that face really exists at that location in space, but it doesn't. It really exists in the component, but the proxy is able to put together where the occurrence is in the assembly and where the real data in the component, and then make it look like that face really exists. And so if you've used the Inventor API at all, so this is the same concept as Inventor has, but the API is implemented quite a bit different than how it was in Inventor. In Inventor, there were duplicate objects. So if we had, say, a face object, then there was also a separate object called face proxy. And but in Fusion, there aren't duplicate objects. So there's just a face, and that face can behave as the real face, or it can behave as a proxy. And so that should be they have the full path. But so how proxies work is they know about the real object, in this case that face, and then they also know about the path. And I'll show you some examples, a little bit of what I mean by path, but the occurrence path to get to that geometry. So all objects that can act as a proxy have these functions on them. So they have a property called assembly context, and that is part of getting this path, which I'll show you in a second. They have a property called native object, and so if I call that, that will give me the real face, or whatever the real object is inside inside the component. So I'm no longer getting a proxy back, I get the real thing. And the create for assembly context, that's if I have the real thing, but I need to create a proxy. And I'll maybe talk about that in a second, hopefully I remember. So let's go look at these past things. And I've written a little add-in that hopefully will help in making this a little bit clearer. And I understand this is can be a little bit confusing, kind of slightly complex, but all right. So let's so I'm going to activate this component. So this is just a UI thing again, right? So now when I create a sketch, it's going to be created inside the active component. If I was doing this through the API, I would have to traverse through the object model to find that component and then get the sketches collection on it to get the same result. But I just want to have some sketch data in here too, besides just the solid. All right. And I added that, so that sketch got added to the component. There are two instances of that component, reflected through these two occurrences. And so I see two instances of that sketch. And let's see, let me just add some geometry into this one too. Okay. So now let me run this add-in. And so first, so this body, remember, just we created that in the root component. So if I select it, then what it shows me in this dialog is kind of the path to that. So it's just in the root component, and it's a face. All right, so there really is no path. So it's at the top level. It's a face at the top level. If I pick this face, all right, so we start at the root. We go to component 1.1, and Fusion helps with this a little bit. You can see, if you look close, kind of the dashed line underneath the component 1.1 in the browser. So that's showing me kind of the path of what I picked. So that face exists relative to component 1.1, and it's a face. All right, so that's the path to that particular face, because I'm going through component 1.1. If I pick the same face in this other occurrence, right, that's in component 1.2. So that so this is the occurrence. So I start at the root, but then I'm going, the path is through occurrences. So I have these two occurrences. So I go through component 1.1 to get to one face, and I go component 1.2 to get to another face. So that's what a proxy is really remembering. It's remembering this path and the real object inside the component. If I pick, say, this face, so now it's deeper. So we start at the root, we go to component 2:1, and then component 3:1, and then get the face out of it. So this path could be very deep. Doesn't really matter, but Fusion is figuring all that out for me and giving me back this face proxy that represents that face as if it really exists in this top level assembly. So that's kind of that is what's really nice about this from an API user perspective, is so that these proxies exist, but in most cases, because of this, because proxies do exist, you don't really have to know that they exist. You just get the thing back that the user has selected or that you queried somehow, and you just use it as if it really exists. And you don't have to worry about, oh, well, this really exists in this component, but it's through these occurrences that have these transforms, and so I have to do all this work to really get it in the correct position. You don't have to do any of that. Just Fusion handles it all automatically for you. And the same happens with sketches. So if I pick the sketch line, so that sketch line is different than this sketch line because of the path. And so if I query those lines for where they exist in the model space, I'll get two different answers. The endpoints will be different for each of those lines, and because of that path. So let's see, there was, oh, and then there's create for assembly context, and where that can be used. So it's not real commonly used, but let's say you're building a bolt that then you want to insert into your assembly. So you would create a new component. You would draw whatever features you need to make the geometry for that bolt inside that component. And so now you know about that, all that data relative to the component. So inside that opaque box. So through the API, it's not opaque. Through the API, you can go and query it, and that's actually where you're modeling and doing all your work. But now you've built that bolt, and now you want to use it in the assembly. So that bolt only exists in the assembly as a reflection through an occurrence. So this create for assembly context is I could find, say, the circular edge that's between where the shank of the bolt connects to the head. So I could find that edge, and so I found that edge relative to the component, so that's the real edge, and then I can call create for assembly context and pass it the occurrence that I want to create that relative to, and so then that builds up that path. And so now I have a proxy of that edge, and now I can use that edge to create a joint, because I couldn't use that edge as it exists in the component because it doesn't know what I mean. So it's just the same as, so that edge that I've just selected in the model, if I want to use that, if I found that in the component and I said create a joint to this, it doesn't know which edge I'm talking about in the assembly, because in this case I have, you know, 2 edges. I could have 100 of those edges depending on how many occurrences I have. So I can't give it real geometry. I always have to supply a proxy when I'm creating joints or doing anything else in the assembly, because as far as the assembly is concerned, that real edge doesn't exist. It's only exists as it's reflected through an occurrence. Right, so here's some kind of interesting behaviors. So you could probably substitute some other words for interesting, weird, or whatever. But occurrence transforms are always done at the root level. And so what that means, so let's say, well, that assembly we just built. So I created that one block as an occurrence, and then I copied it. So we've got 2 occurrences. And well, that's actually not a good example. Let's see. Yeah, so inside this component, and let me make another shape. Okay. Whoop, except I want that shape as a new component. All right, so I have component 2, and it contains occurrences for component 3 and component 4. Right. So if we go inside that component 2, and through the API we can query and find it has these other components, and they'll have a position with respect to component 2. Right. But that's position is ignored by Fusion. And let's see, let me make a, I'm going to copy. So copy, paste. Right, because now I can come in and just move this part all by itself. And so moving parts around in space is always done at the root level, and Fusion remembers it overrides the positions defined in any of the subcomponents. and all positions of all components are remembered at the very at the top level at the root. Right. So if I was to go into this component, into component 2, and find component 3 and 4, and move those relative to component 2, I wouldn't see anything happen inside this assembly. This is different than it would have been in Inventor. And so if you're familiar with Inventor, it's like Fusion. Now I forgot the term in Inventor. You could turn on in Inventor so that you could pull apart a subassembly. So usually it was static, but you could set a switch so you could move parts around independently, and Fusion always behaves like that. So positions are always remembered relative to the top level. And then another interesting thing is that features exist in components that they somehow affect, and this this I want to mention, probably not go into a lot of detail because probably won't affect most people, but it could if you're doing if you're querying features, and because the UI hides some things that are going on. And so let me create a new design here, and I'm going to create a box, and this is going to go into a new component, and I'll create another box, and this is going to go into a new component. All right, and I'm going to create a fillet, and I'm going to pick edges from both of these, and okay. All right, so what I see in the timeline is that I have one fillet, but I really don't. Fusion really created two fillets because I picked geometry from two different components. And so Fusion created two fillets, and if we query the model using the API, we'll actually see, if I go to component 1 and look inside it, there'll be a fillet feature there. If I go to component 2 and look inside it, there'll be a fillet feature there also. And there won't be a fillet feature in root because there is no geometry in the root that got affected. And so even though the root was the active component when I created the fillet, the feature doesn't really care about what's active. It looks at what geometry was affected by that feature. And so those, in this case, two fillet features got created, one in each component, but just one timeline node got created. And if I pick edit feature, then the edit feature command understands understands this, and so it goes and it finds both of those features, kind of combines the information up so it remembers which edges, so it finds the edges in each of the components, and it combines that all together and then displays it in the edit feature dialog. So the UI is hiding the fact that there really are multiple features, but the API doesn't, and so you'll find that. And the API does support, to help with that a little bit, I didn't write it down, but there's a property on features that lets you get, if there are other features related to that, kind of grouped together like this, and then you can get those other features. So I know this was kind of quite a bit of a little bit of confusing information thrown at you at once, but hopefully this helped. And say the main thing is to remember that you have these containers that you're adding data to, and then with components, you're always seeing that data reflected through an occurrence. So it's occurrences that you see in the browser. And so here's what's coming up. So today, this document structure. Thursday, in 2 days, we'll talk about model geometry, and then the next 3 sessions, it's kind of up to you. So let me know what you'd like me to cover in the areas that you're using and need some help with, and good chance some other people need the same information, so we can do just a short presentation for everybody. So you can send any suggestions to the email, that Fusion Hackathon at Autodesk.com email. And so we'll go ahead and open it up for questions. And so yeah, you can type in, or say just raise your hand, and I can unmute you so you can just ask your question either way.
Hey Brian, this is Wayne.
Hey Wayne.
Can you hear me okay?
Yep.
Do you have time to go through some of that code that looked at the proxy information with the select?
Sure. Yep.
I'm kind of curious about how that works.
Okay. Yeah, that's a good thing. So let's see, one question came in. Does it mean that grouping the features of components for editing is bad practice? And no, I wouldn't say it's bad practice. In fact, well, you don't really have control over it. It happens automatically if you pick geometry from multiple components. Another way it happens is if I do this. So I'll draw a sketch on this face. And then extrude that. And now, because that extrusion impacted 2 components, I'll have an extrude feature in both of those components. So I don't, it's not bad practice, because that's what Fusion supports, and that's just how it behaves. But it's just not, through the UI, you would never know this is happening, right? It's just more of kind of a warning that you would be, if you're writing something where you need to really go in and query features, you're probably going to get different results back than you were expecting, because underneath it's really creating multiple features, but the UI hides that. So it's not a bad thing, and that's how Fusion is designed, and it behaves okay. It's just not what you would expect is happening under the covers. All right, so let's look at this little program. All right, so most of this is what we talked about the other day on.
Yeah, so I'm not seeing the code.
Oh, it's really, well, why isn't it showing up? It's saying that
Could you try to maybe stop sharing and start sharing again? Because mine it looks like as if it paused or something.
Yeah, I see that extrude never showed up either, right? Where I cut through both of them.
Yeah.
I did do a stop and start, but it's still not updating. It's saying everybody's up to date. But that's weird. Let me change presenter and then back to me.
Yeah, we can do that.
I just changed it to Wayne, and then.
Okay.
And I'll go back to. Oh, maybe you have to change it to me. I don't see me showing up now.
Yeah, I made you presenter.
Yeah, let me. Actually, I think GoToMeeting is crashing on me here.
That's why then. Okay.
So let me. I'll just get back on. Give me 30 seconds here. All right. So here's the code. And so this is the command created handler. Right, so this gets called when the button gets clicked. And I'm just adding a selection input and a text box input where I'm displaying the results. And so that just sets that up and then hooks up to the input changed handler. So here's where all the work is happening. So this gets called every time I select something. And so it's getting whatever changed. And I'm checking to see, and that should always be, but I'm still checking to see if it was, because there's nothing else on the, or yeah, there's nothing else on the dialog, no other inputs. But I checked to see if it was the input that I named select ent. And then if it is, I get, well, this is just casting it so that the code hints work. So this doesn't really do anything, that line. But I check to see if there's more than one thing selected, because they could have unselected, so that would have caused the input change handler to be called, and there would be nothing in it. But I check to make sure that there is something selected, and I get whatever has been selected. And then I call this little function that I wrote called getPath, and we'll look at that, because that's really where the interesting stuff is as far as getting the path. And then once I get back the path, so that has the path without what got selected. So when we were looking at the results before, it had a path, and then at the last thing it had brep face or sketch line or whatever I picked. So the path that comes back is everything except the brep face or sketch line. And these next lines, they use something to extract and get that little name and then append it to the path. And then it displays that result in the text box. So it's this get path is the more interesting one. And here it is. So not too much. In fact, let me delete that so it's simpler. So it starts out initialize this path to just an empty string, and then it checks to see if the passed in object has an assembly context. It calls the assembly context property on whatever entity I passed in, and if it does have if the assembly context property returns something, then it's a proxy. If it doesn't, then it's not. It's just at the top level. So if it doesn't have an assembly context, then we do this else statement, and I just set the path to root. So the object is going to, the full path in that case is going to be root / whatever the object is, root / brep face. So it isn't a proxy, it's the real thing. But if this assembly context returns something, and it's going to return an occurrence, it always returns an occurrence, then I enter inside this if statement. I get the occurrence, call that assembly context property, and get the occurrence, and then append that name to the path. So if it's currently empty, then I just assign the name to the path. If there already is a path, then I add that / and add the path to the existing, to what I currently have. So it gets the name of the component, or the name of the occurrence, and uses that as the path. And it does that in a while loop. So then I get the assembly context. So we're starting at the bottom and looking up the tree. So let's say we have the root component, and then we have occurrence 1, and inside occurrence 1 is occurrence 2, and then inside occurrence 2 we have a block, so we have a face. Okay, so I pick that face. When I ask that face, what's your assembly context, it's going to tell me occurrence 2. So it's the immediate occurrence up above. And that's actually, that occurrence is actually a proxy, because then on the next while, so it calls on that occurrence, it gets its assembly context, and then that's going to return occurrence 1. And then that occurrence isn't going to be a proxy. So when it gets the assembly context, that's going to be nothing. It's going to be empty, so it will drop out of the while, and that builds up the path. So it's using that assembly context property to get the so it's stepping up the tree. So we start at the bottom with the face, we get the lowest level occurrence that face exists in, and then from that occurrence we can get the occurrence it belongs in, and then from it we could get the occurrence it belongs in, and so we can step back up until we get to root, and that builds up that full path. And so everything, including occurrences, are proxies unless they exist at root, because I can have multiples of those. Right, so I have to have a proxy that represents each one independently from the other, because if I have a subassembly that has 2 occurrences in it, and then I make a copy of that subassembly, now I have, how do I specify one of those occurrences from the other? And it's through that path again. So occurrences can be proxies. Amar asked how to activate prompts in Spider on the Mac, and I don't know. I hardly ever use Mac, and I would have assumed it already works, but if so, by prompts I assume you mean code hints as you're typing. Hey, Adam, have you had any experience with this, or do they not work on Mac?
I think in both for JavaScript and Python there were suggestions, but I'm not sure how accurate they were. They just suggest whatever. If you're talking about IntelliSense,
Yeah.
not sure how much I could trust it. But it seemed to be on, so I don't remember switching it on.
Yeah, I would have expected it to be the same as in Windows for Spider. All right, any other questions? A big one from Patrick. Let's see, I'll just read it out loud as I read it. So how do you create a collection? In the case I need a specific group of objects to use as input to another command. For example, in the UI, to create a split button in the nav toolbar, the second argument is a collection. And in most cases, that's an object collection. So it's just kind of a generic object in the API that is used both for input and output. So it's like in the case he mentioned here, where you need to supply a group of things, then it's used as input. And a lot of times when an API is returning a group of things, it will return them as an object collection. And so to create it, there's a static method on the object collection itself called create. And so it would be something like this if I wanted to create a new object collection. Right. So that creates a new empty object collection, and then I can add stuff to it now by calling the add method. And so whatever I want to add would go in here. So if I had a variable face1, and right, any other questions? So related to, I mean, this presentation or anything else is fair game too. And so we'll have another question and answer session tomorrow at 9:30 Pacific time. And so we changed it. So there's an email sent out saying that we've changed these from an hour to half an hour. Basically what that means is that we'll be online for half an hour, and you could come in anytime during that time. But if we get to the end of the half hour and there's still questions, we'll stay for as long as we need to. It's just there hasn't been a lot of attendance at these sessions, and so rather than having to hang out for an hour, we'll just be here for half an hour, and you can come anytime, and like I say, we'll stay as long as we need to get all the questions answered. So.
Now we'd just like to reiterate that we would really need you to, suggest topics that you would like Brian to present, because it's not set for quite a few of the sessions coming in the next couple of weeks.
All right, well, that seems to be it for today, unless somebody has a quick last minute question. All right, well, thank you for